Alrighty, so on Friday we derived those fantastic formulas. It was a lot of fun. I'm sure you went home smiling at how much fun you had in physics that day. Nate, you're killing me, man. You're hurting me. Okay, so today I'm going to do two sample questions and show you sort of how to use them. So here we have an object of mass 1.5 kilograms, so it's pretty heavy, tied to the end of a string 0.5 meters long and swung on a horizontal circle with UCM. Uniform circular motion, which is basically everything we're talking about. Uniform circular motion means that the speed remains constant. Such that it makes 5 revolutions in 4 seconds. Find the frequency, find the period, find the speed, find the centripetal acceleration 2 different ways, and the tension in the string. Okay, so one thing that we haven't talked about yet is frequency. We've talked about period, but we haven't talked about frequency. Okay, so the frequency is, usually we just let the letter F represent frequency, and it's the number of revolutions per second. Okay, so in this case here, it's making 5 revolutions in 4 seconds. Frequency, F-R-E-Q, is equal to F, is equal to revs per second. Revs. Revolutions per second. We use little f. Yep. And there are some letters that are multiple used. So in this case here, we're going to take 5 and divide by 4. And so our frequency is 1.25 revolutions per second. There is a special word for revolutions per second. The unit is hertz, like megahertz or gigahertz. The abbreviation for that is capital H, lowercase z, hertz, named after some guy named Hertz. The period then is the time it takes. Period is big T. Period, Nate. Time for 1 revolution. Okay? And a sort of a formula. Period and frequency are related. The period is equal to 1 over the f. They are inverses of each other. Period is equal to 1 over f. It's an equal sign. And f is equal to 1 over t. Okay, so in this case here, period is going to be 1 over 1.25. I should also point out that that's going to be the same as 4 over 5. If the frequency is 5 over 4, the period is going to be 4 over 5, and your period is 0.8 seconds. So I would expect you to be able to sort of handle any problem. It gives you the frequency, you got to flip it to period, convert back and forth. It's pretty simple. Okay, let's go now to part C, which is the speed. Okay, so it's going around in a circle, horizontal circle like so. The speed is the distance divided by the time. Or because it's a circle, that's 2 pi r over the period. So I'm going to switch the small t for a big T. Radius is 0.5 meter. Period was 0.8. Circumference. Circle. Circumference. You get 3.93 meters per second. So the next part is where it gets a little trickier. We're going to find centripetal acceleration. Now I gave you two different formulas for centripetal acceleration, or AC, acceleration centripetal. I told you that it was equal to V squared over R, and here, Nate, is where we're using V, but we really mean speed. Okay, you guys put the phones away. Yeah, because we can't really be talking about velocity, really. So we're going to go 3.93 squared centripetal acceleration all over 0.5. $30.9. S looks a lot like a 5, so I don't think you don't really see S a lot in formulas. Yeah, 30.9 meters per second squared. And that is directed which direction, Cole? Centripetal acceleration. Want to change your answer, Billy? Or stick with outwards? Mitch, break the tie. Centripad, yes, centripetal. Inward. Because the force is in, right? You can only pull on a string, you can't push, right? There is no force out. It's inertia. Centripetal, it's in. Okay, now it says to do it two different ways. The only reason I do that is just to remind you that there is a secondary formula, which is 4 pi squared r all over t squared. I'm just showing you that there are multiple ways to do it. Okay? When would you use this one? You would use this one when you don't know the speed. Big R is, I don't know why I do that, yes. 3.14 squared. Well, I used a pi button on my calculator, but you're right. Good point. I wouldn't expect you to do it by hand. So 4 pi squared, the R is 0.5, and the period is 0.8 squared. Make sure you be careful here. Just a reminder that it's pi that's squared, not the R. Okay, Nate, pay attention and watch your mouth. What should you get? You should. I think you get, if you round it properly, you get 30.8. But it should be the same. It's likely a rounding error. Or the fact that pi, or remember we rounded at 3.93, right? So that's probably where it comes into play. It's probably rounded up. So you can do that either way. Again, the one on the right would be used if you don't have the velocity. Okay, so the tension in the string, I'm going to add another page here. The tension in the string is a fancy way of asking for the force, right? The tension is the centripetal force, right? And so there are actually 3 ways to do it. The easiest way at this point is our old friend, F equals ma. The tension in the string that we normally talk about as a big T, I guess maybe we should be calling it Ft, but it's the centripetal force, right? Force, the tension in the string is what's providing the centripetal force. Okay, so we're going to use our old grade 8 friend, F equals ma, but the F is centripetal force and the A is centripetal acceleration. So it's just going to be the mass, which was 1.5, times that value that we came up before. I'll use the 30.8, just because that's what I've got on my paper. Again, if you show me your work, I got no problem with this. I get 46.2 newtons. Now, is that the only way to do it? Nope. Because we learned yesterday, or Friday, we used FC equals mv squared over r, right? If you use that, you're going to get 46.2. I'm not going to do it. You guys can do substitution. Nate, you can do substitution. You can also use FC is equal to m4 pi squared r all over t squared. I always pull this one out. You guys remember the magic triangles? Did anyone ever show you the magic triangles in science class, solve formulas?
Pascal's?
No, not Pascal's triangle. The magic triangle where you got like F equals MA and you cover up the F and you go M times A and stuff like that.
Oh,
Yeah. Yeah. When kids want to do magic, when kids that I know are going to arrive with being grade 12 physics, they want to do magic triangles, I pull this one out and I say, okay, show me the magic triangle for this one. And they can't do it, and that's why the magic triangles are bad. They're evil. They're evil. They're like crutches for people.
What? Crutches for people?
Yeah, people that don't need them, right? Okay, any questions with this one? This one's pretty straightforward. Just reminding you about problems. Okay, let's go to sample number 2. I might need to wait a second for Keith and Noah. Do you guys need to write this one down? Or do you have it? Okay, I'll wait for you. Okay, so this one's got a little twist to it. Today we're just dealing with horizontal circles. Nick, are you with us? Okay, so you will notice that it says here a string can withstand up to 7.5 kilograms hung vertically on it and then it breaks. Piece of string 4 meters long is used to whirl a 2 kilogram mass in a horizontal circle. So it is a horizontal circle, but this 7.5 kilograms hung vertically on it it's kind of like the test strength on a fishing line. It's how much it can withstand before it breaks. Well, we have to find that out, right? So the first step is to find the weight force. Okay? And anything, whether it's fishing line or steel cable, will have some sort of test strength, what it's rated to. Right? So in this case here, it's rated to 7.5 kilograms times 9.8. So it's rated to 73.5 newtons. Now that's kind of a weird number, but right, it would probably be rated to like 100 newtons or something like that, something a little more round. And they would, if it actually could withstand 73, they'd probably rate it at 50 newtons, right? Because they know that there's going to be stupid people trying to extend it. That, of course, exists in the real world. Okay, so be careful when you see the word vertically. Is it talking about a vertical circle, because that's what we're going to do tomorrow, or is it still a horizontal circle?
So is this the braking force?
That's just the braking force. That's the maximum. This is the maximum centripetal force. This is the maximum it will withstand before it breaks. Okay, so part B says maximum speed reached. So in part B, the maximum speed reached is when, of course, the maximum centripetal force is there. So we're going to say FC is equal to mv squared. Pardon me, sometimes I put big R on the bottom. I think I tend to do that because my little r's tend to look like V's. Sure. The R doesn't matter. So we're going to use this 73.5 in here for our centripetal force, the maximum centripetal force. Now, watch out, there's 2 masses in the question. Which one is going in a circle? The 2. So be careful, little trick there. So 2v squared, and the radius is 4. It's a really long string. I don't know why I have such a big number. I'm assuming you can make that, you can solve for that. 2 over 4 is 0.5. Divide by both sides by 0.5. Take the square root. Maybe I'll write it out. Okay, so it's going to be 4 times 73.5 divided by 2. Take the square root. You try it on your calculators. Correct. 12.1 meters per second. Yeah, 12 meters per second times 3.5, that's about like 40 kilometers an hour. Okay, last bit, the period of motion at break time. So like how long does it take to make the circle when it actually breaks? Do you have this formula? I think you do. T equals, it was one of those saved equations. Can't remember. Period is, oh, I know. No, it's simply 2 pi r, the circumference, right, divided by the speed. Right? This is equivalent to v equals d over t. The displacement is the circumference, 2 pi r over time, and you just switch the v and the t. I'm just showing you where this came from, right? Velocity is distance over time. The distance is 2 pi r, circumference. Little t is the period, big T. You just switch the v and the t, and you get t equals 2 pi r over v. We're looking for the period.
Yeah, but the R is still 4.
The r is still the 4. So it's going to be,
V is still 12.
yep. So it's going to be 2 times pi times the radius 4. We're going to divide by the speed, which is that 12.1 number. And we're going to get 2.08 seconds. That's the time it takes to make that, like that's a big circle. Okay? So more than anything, I'm just reminding you of the formulas, giving you sort of a heads up of what kind of problems you're going to be seeing. I got a problem pack here for you. I posted it to Schoology this morning. Hopefully you guys can get to it and print it. There's a picture of an old-fashioned granny record player. Question number 3, and then the second page has a guy riding a bike, and then the last page has a little truck on the back. Okay. I noticed that I don't have the solution links here. This must have been one of the last ones that I didn't do solutions for, but I know I've got solutions, so I will post them to Schoology momentarily so you can get to them. Your physics exam is now Wednesday afternoon. No, 2 weeks.
Yes.
Wednesday afternoon. It moves it away from the pre-calc. The only person that's affected is Josh, so you can give him a fist pump for saying it's okay with him. And you also have to thank me
Why did it affect the job?
because he's got the essentials exam in the morning. You can thank me because I'm, well, because I did it for you. And I've also got, you should be aware that I've got my grade 10 computer science class going on at the same time. So I'll be back and forth between you guys and them. You guys, yeah, put it in your phone. The 15th, I believe. 15th. I'll put it on Schoology. 15th at 1 o'clock. You guys will write, you guys from here at the DR will write in my classroom. 1 o'clock.
Are these guys gonna have to come down too?
No, they're writing in their own schedule. It's 2.5 weeks away, that's right.